You're listening to the Maritime Gardening Podcast, brought to you by Vessi Seeds. And today we've got Keith Reid here to talk about nitrogen, everything you ever wanted to know about nitrogen. Who is Keith Reid? Keith Reid is a soil scientist. He has his BSc and MSc at the University of Guelph. It's in Ontario. He worked for the Ontario Ministry of Agriculture, and he worked for Agriculture and Agri-Food Canada, and he's the author of Improving Your Soil. And I'd like to show the book. And I've read his book, and I've had him on the podcast to talk about the book. But I cleaned my office a month ago, and I was looking for the book this morning, and I can't find it anywhere. There's a number of things missing. I know it's in here somewhere. Anyway, I'll put it up on the screen. I'll just put an image up. It's a great book. I recommend it to anyone. You don't need to be a commercial farmer to read this book. Any home gardener would improve their knowledge about soil by virtue of reading this book. Keith, hello. How are you doing?
I'm doing well. And if we're going to talk about everything about nitrogen, yeah, an hour's not long enough. We would need several hours, but we'll try to keep it relevant.
Okay. There's a guy I have on my podcast a lot, Robert Pavlis, and that's his go-to thing when people, are talking about, what can I do? What's wrong with my plant? Blah, blah, blah. It's probably nitrogen. It's like the least stable thing. So that's what got me thinking of, the topic of today's podcast. So I have a whole bunch of questions I'm going to ask Keith about nitrogen, and we're just going to try to fill up an hour going through all of these. Because if you understand nitrogen, you'll probably be doing a lot better as a home gardener.
That's right.
So let's just get started. What is nitrogen?
Okay. Pretty common element. 78% of the air we breathe is nitrogen gas. And two nitrogen atoms stuck together is a very, very stable compound. Not reactive at all. The only time it causes trouble is if you do deep sea diving and nitrogen dissolves in your blood, and it's the bubbles coming out when you come back up to the surface that causes the bends.
Yes.
Other than that, nitrogen is pretty benign. Trouble is, the nitrogen gas in the air we breathe is absolutely useless as far as biological systems go because it is so stable.
Right.
So plants can't absorb nitrogen directly out of the air. Animals can't use nitrogen directly out of the air. It has to be converted into some other form of nitrogen for living organisms to be able to use it.
Right. So we're surrounded. We need it, and we're surrounded by it, but we gotta eat something or drink something to get it into us. We can't breathe it.
We can't. Yeah, we don't get it through breathing. We get it through what we eat, and plants get it. Before commercial or industrial nitrogen fixation, they got it, from bacteria, other organisms in the soil that harvested energy from elsewhere to break those bonds and create other compounds. So
okay, well, so before we get ahead of ourselves, because I think we've got a couple questions here that kind of get into that.
Yeah.
So why do plants need nitrogen?
Okay. Pretty important in the plants. Every protein, every amino acid is made up of nitrogen compounds. They have amine compounds, so nitrogen and hydrogen stuck together. So chlorophyll is a protein backbone. The green chlorophyll that harvests the sun's energy requires nitrogen. All of the proteins in the plant, DNA, our genetic material is a nitrogen backbone. So it's
Wow.
it's in every cell. It's involved in pretty much every reaction within the plant and within animals and bacteria as well.
Wow.
So it's it's an essential nutrient, and it's one of the largest quantities in plants and in animals in terms of, if you broke us down, the biggest parts are carbon, hydrogen, oxygen. Next on the list is nitrogen.
I see. And without it, we're doomed.
Exactly. Yeah.
It's like a key component of carbon-based life.
Exactly. Yes.
Okay. Now, how do plants get nitrogen?
Yep. So plants, all the nitrogen they get, I shouldn't say all the nitrogen, but most of the nitrogen they get, they absorb from the soil, take up through the roots. Plants can actually absorb nitrogen through the leaves.
Hmm.
So, that's why sometimes foliar applications, look like they do something phenomenal because they get a little bit of nitrogen through the leaves into the plant right where it needs it at the time, and you'll see an immediate, green up. But it's a pretty small amount that plants can absorb that way.
Right.
And
And generally speaking, in nature, that's not going to be. There'll be a little bit of nitrogen
there'll
stuck
be
in the rain. A bear might pee on the plant. It's
yeah,
not too
yeah, but
many.
most of it is through the roots.
Okay,
Most of
and
it's,
it,
and even foliar nitrogen. Most of it runs off the plant down to the soil,
right.
taken up through the roots.
Or it's like a fertilizer spray,
Yeah,
basically.
exactly,
Yeah.
exactly.
And
Yeah,
how are they getting it through the roots? I mean,
yeah, yeah.
what,
So getting it through the roots.
or put it another way,
Yeah,
why is there nitrogen in the ground?
yeah. Why
You
is there
know?
nitrogen in the ground? Yeah, and that's where um, lots of we could spend an hour in the nitrogen cycle.
Yes.
Yes. uh, first step is converting that nitrogen gas into ammonium. So uh, that's what the rhizobia bacteria associated with legumes will do. There's free living uh, cyanobacteria in the soil that will take that very strong bond and break it and combine that nitrogen with hydrogen to get ammonium, which plants can use directly. Trouble with ammonium is it has a positive charge, so it sticks to the clay minerals, it sticks to the organic matter in the soil. It doesn't move easily with water.
Ah,
There's other bacteria that will use the ammonium and convert it to nitrate. And nitrate moves very easily with water. So most of the nitrogen taken up by plants is actually in the nitrate form, just because it moves with the water. As the plants
oh,
take up water, it just pulls that nitrate with it.
so ammonium is, you could say ammonium is relatively stable in soil compared to nitrate, which can be rained away.
Yeah.
Is that okay?
Yes. Yeah.
Okay.
Yeah.
Oh, interesting. I
Yeah.
didn't know
Yeah.
that.
But the drawback with nitrate, yes, it can be rained away. It can be leached out of the soil. Um, but it also means it's mobile in the soil, and plants can get at it easily. Where
Yes.
the ammonium, the roots have to grow close enough to a clay mineral to be able to absorb it by diffusion.
Right.
Which
Or if you have
so
a fairly healthy balance of organic life and organic matter in your soil, there's probably a more more opportunity for the ammonium to be changed and turned into nitrates.
yep, yep,
Okay.
yeah, yeah. Warm, moist conditions. You
Right.
know, lots of bacteria in the soil that are ready to do that.
Yeah.
Um, and that leads to the other part. In the soil itself, the biggest pool of nitrogen is actually in the organic matter.
Right.
You know, we've it's broken down plants and animals. It's got a part of the nitrogen that was there originally, and it's bound up in compounds in that
Oh,
organic matter. So we might have, if you like, in an acre of topsoil, we might have 3,000 pounds of nitrogen in the organic matter. Uh, as that breaks down, or as it cycles back and forth between the organic form and mineral form, you know, we might get 100 pounds out of that 3,000 pounds released into the soil.
and is the nitrogen in the organic matter, is it broken down into ammonium or nitrate, or what is it?
Yeah, it will go from organic matter to ammonium,
I see.
and then converted to nitrate.
Okay, so there really think about it, in soil there's three kinds of nitrogen.
Yeah,
There's
yeah,
ammonium, there's nitrate, and then you've got this nitrogen raw material that's
exactly.
in the
Yeah,
process of becoming either ammonium or nitrate.
yeah, yeah.
I
And
see.
the complication is that organic N, um, not all of it breaks down equally quickly.
Yes.
There's differences in the compounds. There's different, and usually it's tied to mineral matter in some form, or hidden inside of a granule of soil, and so it's not all available, and
Yeah,
we don't want it all to be available.
right.
It's kind of like, yeah, you want the structure of the cake, and we can skim off some of the icing, but you don't want to take the cake away, or else the soil falls apart. We lose a whole lot of other things that organic matter does for us.
Right. I see.
So when we talk about, well, getting, we can get all of our nitrogen from organic matter, only if we're breaking down that organic matter and using up the part in the soil that we want to keep.
Yes. Yes. And I mean, there's such a range. I mean, you could have I got a bucket of sawdust and a bucket of grass clippings. After 2 weeks, the bucket of sawdust is still a bucket of sawdust.
The bucket of grass clippings is,
Oh,
yeah.
You wouldn't want to leave that in the bedroom.
No. Yeah. And actually, that opens up another complication. If you mix that bucket of sawdust in the soil, that sawdust has a lot of carbon and a little bit of nitrogen.
Yes.
We talk about a carbon to nitrogen ratio. So sawdust has about 200 parts carbon to 1 part nitrogen.
Right. Yes.
Put that sawdust in the soil. The bacteria, the fungi in the soil say, "Oh, food," because they use carbon compounds.
Right.
Will immediately set to starting to eat that, grow and multiply. But to do that, they need nitrogen.
Right.
So what do? Oh, we've got some ammonium, we've got some nitrate in the soil. We will absorb that, use that for our growth,
Right.
and convert that into, bacteria bodies.
Right. Yeah. Yeah.
And when you consider, you've got 6 billion bacteria in a teaspoon of soil, then you're one lonely little plant. Yeah, the bacteria get it first.
Right. Yeah. And so you're not. I mean, the net effect is that you still have plenty of. Let's say you had really good soil with all kinds of nitrogen.
Yeah.
You
The
still have
nitrogen's
all
still
kinds. It's still there.
nitrogen's still there, but
Yes.
the plants can't get at it. Somebody else has
Right.
got it first.
You're right. It's sort of being
And
borrowed.
yeah,
That's right.
and until they use up the extra carbon compounds, that stays in the organic form.
Right. Well, I guess that segues in a sense to the next question, which is why do some plants not get enough? So one example is the artificial situation where someone tills a whole bunch of you know uh, organic matter that's high in carbon and low in nitrogen, and for whatever reason they do this because it makes them feel good, or maybe it changes. They want a nice light texture to the soil, and then they have this catastrophe where everything's growing really poorly and looking pathetic. But aside from that, aside from those sorts of situations where the gardener makes a huge mistake, um, what are other situations where plants wouldn't? Because I think this is, a gardener has and I did a video this summer where I had this idea. A lot of people were saying this summer they had a lousy garden. And I had some things that didn't do well, but generally speaking, I had a good garden. But I did have a few beds where the results weren't that good. And people thought, oh, it's just a bad summer. It's like, oh, we had lots of heat. We had lots of sun. It was ridiculously hot, sunny, warm. I mean, the whole place, my province is on fire. We had a lot of heat. And a lot of heat early, right? Like it's not like the worst garden I ever had was 2015 because the soil was still frozen at the end of May. And it just took forever to get things germinated. And you stick your transplants in and you didn't realize it, but you were like killing 80% of the root mass of the transplant because soil is so cold. So my theory was that we just had this massive washout of, according to you, nitrate, and that it's the beds I kept mulched with a really good organic mulch grew really well, and the beds that I didn't have much mulch on, or maybe I just like done something lazy, like put cardboard on it just to keep the weeds down, but there's no nitrogen there, and you have this insane amount. We had a ridiculous amount of rain this summer, over and over, floods, bridges we still have not been repaired here in Nova Scotia for flooding. Yeah, that was my theory. But anyway.
And Yeah, nitrogen is so slippery; it's hard to know exactly where it's all gone.
Yes.
But you're describing a situation where, yeah, warm or hot and dry early, and then a lot of rain, mid-season on. Um, you've got conditions where the soil, because it dried out, you've got lots of air in the soil, so it's easy for bacteria to convert any ammonium to nitrate. So you get an
Okay.
accumulation of nitrate in the soil. You get a heavy rain. If it's a well-drained soil, a gravelly soil, it'll wash that nitrate out, carry
Right.
it below the rooting zone. So,
Mm.
yes, you had enough there. Plant can't get it because the roots aren't deep enough. The second thing can happen especially if you've got a soil that's got a fair bit of clay in it, doesn't drain that well. The soil saturates. There's bacteria, because nitrate, it's NO3, 3 oxygens to 1 nitrate.
Okay.
There's bacteria in the soil that say, okay, soil's flooded. We've used up all the oxygen gas. What's the next easiest source of nitrogen, or of oxygen? They'll grab the oxygen off the nitrate.
I
So
see.
we call denitrification.
Oh.
Takes that nitrate, turns it back either to nitrogen gas
Oh.
or to nitrous oxide.
I see. Probably fun
Yeah.
for a party, but
Well, yeah, we may get back into, nitrous. The trouble with nitrous oxide is it's one of the greenhouse gases.
Oh, okay. Yes.
Yeah, so we
Okay.
don't. Yeah. So doesn't matter whether you've got a well-drained soil or poorly drained soil. Too much rain means you lose nitrogen.
I didn't realize that. So, okay, so if your soil's flooded, I mean, this isn't every organism. A lot of organisms will die in flooded, but I guess anaerobic
Yeah, yeah,
ones
yeah,
can
yeah.
find their air.
Out of those 6 billion bacteria, there's probably 3 billion that either can use nitrate,
Right.
or what they call obligate anaerobes. They can't use oxygen, but they can happily use nitrate. And when they use up all the nitrate, then they go to sulfate.
Right.
And what you get when they take the oxygen off sulfate, they'll release hydrogen sulfide.
Well, that's good.
So
Yes.
yeah, if your soil is, you've got a really wet spot, and you stick the shovel in and it stinks of rotten eggs,
Oh, that's that low tide smell,
that's
right? Yes.
hydrogen sulfide.
I see.
If you're getting a hydrogen sulfide smell, you're long past having any nitrate left. It's
I see.
it's gone before the bacteria will turn to sulfate.
Right. That's fascinating.
Yeah.
Oh,
So
that's what
it's
I thought.
yeah. So those are conditions. Yeah, those are conditions where there could have been enough nitrogen in the soil, and then you lose it. A lot of natural systems just are not that high in nitrogen to start with.
Right.
If you look at uh, what we get out of the air, so we'll get a little bit of nitrate deposition when you get lightning.
Right.
You've talked about that. You get a thunderstorm, there's lightning. Lightning strike will fix something like 6 kilograms of nitrogen. Uh, but 6 kilograms over the length of a lightning strike is not very much in the rain.
Yes.
Uh, we'll get a bit of a ammonia deposition. If you've got a hog barn upwind, some of that ammonia that's released from the hog barn will waft over and will land on the soil.
Right. Yeah.
There's free living bacteria in the soil, will fix a bit of nitrogen, but there's not a lot of nitrogen from those sources. The big natural sources are the legumes.
Right. Can you
Yeah,
explain how they, just for those that don't
yeah.
understand? I mean, farmers use them and gardeners use them, but in nature we've got things like clover. Well, clover, is clover a legume?
Clover is a legume.
Okay. Okay. All right.
Yep,
Anyway,
yep.
I'll let you talk. You're the expert.
Yeah, yeah, yeah. And legumes, what they do is they form a symbiotic relationship with bacteria on the roots.
Right.
So that's what's inside the nodules if you dig up a legume. So if you dig up a clover plant or you dig up a pea plant, you see these little round or oblong, white things stuck to the root. It's not a pest. It's not a nematode. It's the nodules. And actually, if when the plant's actively growing, you take one of those nodules and you split it open, it'll be pink on the inside.
Hmm.
Because part of the compounds that do the nitrogen fixation in the nodules are iron based, so that's where the pink color comes from
Oh,
when they're active.
wow.
What the nodules are doing is they're getting sugars from the plant. So you've got a clover plant, it's got nice green leaves, it's photosynthesizing. Some of that sugar is going down to the roots, into the bacteria in the nodule. They're using the energy from the sugars to drive nitrogen fixation. So breaking that nitrogen bond, which takes a fair bit of energy, and releasing ammonium.
Right.
So that's
they're not. Yeah. So that nodule it's taking nitrogen out of the air that's in the soil.
exactly, yeah.
Okay. Yes. So it's not the leaves sending. It's not the leaves pulling air and sending leaves. I always thought it was like the leaves, sucking up air and somehow
No. It's the leaves
leaves are just
photosynthesizing.
fueling.
They're sending the fuel down to drive the process.
So they've got okay. So they're feeding the thing
Yep. Yep.
that sucks air out of the soil and makes
Mm-hmm.
ammonium. Huh.
Yep. Yep.
And even then, and so, but then you were saying it's not ammonium that the plants use; it's a nitrate.
Well,
So then there's other things hanging around that are, or is it because it's so close and it's right there?
actually, yeah, it's right there. Ironically, in the plant itself,
Right.
When a plant absorbs nitrate, it converts it back to ammonium to form the amino acids,
Oh, really?
because it's the amines that form the part of the protein.
Right. Right.
So actually, within the plant itself, yeah, some will be converted to nitrate. A lot more of it, in that situation, would be used directly as ammonium.
Right. And
But
when you said it
stays in the
was
plant.
plants can't absorb ammonium, you just said it's more difficult because of its positive charge. It's
Yeah,
sort
yeah.
of
It
stuck to
doesn't
your clay particles.
yeah, it doesn't
Probably.
move to the plant as easily.
Yes,
So plants are adapted to use nitrate.
I see.
But
Yes.
yeah, if ammonium flowed as easily as nitrate, plants would quite happily use ammonium.
Right. I see. Okay.
So,
That's really neat. Um, so I guess that does segue to the next question, which is, what's the best way to maintain? I'm a gardener. I want to get the best results I can possibly get. Um, of course, I'm sure, and maybe you can talk about
yeah.
there is such a thing as too much nitrogen. Um, it's funny if you talk to people about anything like that, even if it's vitamins, people seem to think there's just like there's a more
Oh,
everything needs what it's
if a little is good, more is better.
exactly right. But there
Yeah,
is,
yeah.
the way I always look at it, there's a right amount. Anything more than that is just either uh, a waste of time
You're
or a
wasting.
problem.
Yeah, you're wasting it or you're hurting the plants.
Yeah. So, what's the best way to maintain an optimal nitrogen level in your soil?
Okay. Um, Depends on your approach. You know, if you are trying to avoid buying any external inputs, that means rotating your garden plots and growing legumes for a year.
Right.
Um, and it's a bit of a myth that you could plant beans or peas, and then that will leave a lot of nitrogen behind for the next crop. Beans and peas will fix quite a bit of nitrogen, but then once they get close to maturity, they pull the nitrogen out of the roots and put it in the pea pods or the beans.
Right. No free ride. I mean, yeah,
No,
exactly.
yeah,
When it's
yeah,
not doing this out of the goodness of their hearts.
exactly.
Yes.
So that means either you plow down or work in your beans and peas when they're still green before they start to die down, or you grow a crop like clover for a
Right.
year, and because that will actually, because it's a perennial plant, it will keep fixing nitrogen in the roots and leave more in the soil.
Right.
Uh, so okay, so that's one way.
Would it just to kind of follow up? Would it
Sure.
also be the case that during the season where you're growing beans, and I do that, I kind of rotate beans, various legumes through beans and peas, are the main legumes I grow. I think that's mainly it. But they get grown everywhere over the course of time. Would it also be the case that during the season where you're growing them, you're sort of giving everything else a break?
Yes. Oh
So
yeah, yeah.
there's
There's advantages to rotating beyond nitrogen.
yeah, so there's
You know,
like all these different things living through their life cycle and dying and becoming ammonium, and that's just going to get sort of not used that season. Right? You got one thing that's got all the nitrogen it possibly needs. Doesn't need any nitrogen from your soil. You got parallel processes in your soil that do increase the nitrogen content in your soil. Um, various life cycles of things
Yep.
in the soil, and there's really nothing. uh, Yeah, the soil is getting a break, or the soil is getting a break from nitrogen extraction in a sense. I don't know to what
Well,
extent that's the case.
it's to some extent it's getting a break from nitrogen extraction. It's the bigger impact is just getting a break from diseases and pests that are specific to your tomatoes or your potatoes,
Oh yes, that's
you know, or your onions.
the
It's
main reason
just
to rotate.
that's the main reason that beans and peas will give you a benefit. Um, the break from nitrogen extraction doesn't help us as much as you think because we have a maritime climate.
Right.
We have this thing called winter where it snows and then it rains and then it snows again and then it rains again, and any nitrogen, anything that had been in the soil, um, as ammonium, if it's available, probably got converted to nitrate and then get washed out over the winter.
I gotta. This has nothing to do with what we're talking about. I just have to ask you this because there are a number of very prominent YouTubers
Hmm.
that do videos saying that crop rotation is unnecessary for the home garden. And they say, I've been growing tomatoes in the same bed 10 years. Everything's fine. Haven't had a problem. And they say, um, this is the only proof they give. And then they refer to
Hmm.
other studies where it's been done. I've got my own take on that. Obviously, I don't agree. I rotate my crops because this is what's suggested by reputable sources. Um,
Hmm.
so what do you say to the person that's okay, I've been growing potatoes in the same place for 10 years. Everything's fine. Everything's growing great. This is evidence that you don't need to rotate your crops. This is an industrial level gardening thing.
If he's growing potatoes or tomatoes for 10 years in a row, he's also uh, using fungicides of some sort just
Right?
to control the diseases that build up. I know there was a study done on, I think it was in PEI, or was it Ontario? No, it was Ontario, looking at potato rotations.
Right.
You know, and you know, a rotation with potatoes 1 year and three, and I think they went to barley and then red clover and then back to potatoes.
Okay.
You know, greatly reduced the amount of fertilizer they needed, greatly reduced the pesticides, fungicides they had to use. Um, had higher yields in the potatoes in the potato year.
Mm.
The biggest profit was continuous potatoes.
Yes. Yes.
Even though they had to put a lot more inputs in, just the way it worked out because you were getting paid every year for your potatoes.
Right.
You
Well,
know,
and I think most of these proponents, they're adding like an inch or more of compost to their soil every year. So in a sense, it's not the same garden. Like an inch of compost
mhm.
is a lot of
That is
material.
a lot of compost.
Yeah. So it's really I've never done a video going through all of this, right? But
Hmm.
it's
Hmm.
not it's not so you can't put your finger in the same river twice. You've literally changed. It's not the same spot, like if you
Yep.
know that sort of thing.
Yep. Yep.
I also think it's possible because the sample's so low that they're just getting lucky. Like
Hmm.
there's a risk of some horrible disease getting into that soil that's unique to the thing they're growing, and they've just been lucky enough that it hasn't become or some terrible
Yep.
pest setting up shop, and it's just because they're in this fantastic right place, right time, everything's working out, they haven't had a problem, right?
Yep. Yep.
I think that's also
Ireland grew
possible.
grew continuous potatoes for a century.
until everybody's
with no
kind of dying.
problem.
Exactly. Exactly, right? I mean, until
Yeah.
they either exhausted some crucial element of their soil or just something.
Well,
It
yeah,
was a fungus,
with
wasn't it?
it was Phytophthora infestans,
Right.
late blight of potato.
Late blight of potato. And it was
You know,
bad. It's very
yeah,
bad.
it was very bad. It was very bad.
All right, I got us completely off of topic
Okay,
here because I
okay,
just best ways to maintain optimal
okay,
nitrogen in your
okay.
soil.
So we talked about
Sorry.
legumes. Uh, Second way, yeah, add compost, add manure.
Right.
They will contain a fair bit of nitrogen. Uh, you want to know what's in your compost or what's in your manure, because if it's a lot of organic matter, it will take time to break down.
Right.
So it's not an immediate nitrogen availability. It's a longer term and availability from a compost or from manure. And then the third way is, yep, go to the store, buy a bag of fertilizer.
Right.
And
Exactly.
if you look at a label on a bag of fertilizer, the first number is nitrogen.
Right. Is there any reason? So let's say you've got your 12-12. I mean, I had Lee Reich. He's a, I don't know if you've heard of Lee Reich, but he's a book author. He writes garden books. And I asked him what fertilizers did you use? He said, oh, 1, 2, 3, 3, 2, 1, 12, 12, 12, 6, 6, 6. It doesn't matter. He said something along those. So he's kind of being facetious, right? He's kind of a funny guy. But I mean, generally speaking, I've heard the argument that really your phosphorus and your potassium, it's rare that soils are lacking in these chemicals or the chemical compounds that have them in them. That it's nitrogen that's the thing, but most fertilizers are a combination of all three. But
Yep.
what is there a value in just buying a nitrogen fertilizer, like the stuff you use in your grass, which is like whatever? I think I got something for my lawn. It's like 2500 or something obscene like that.
Yeah. Yeah.
I mean, let's say they all cost the same. Would it make sense to just get a nitrogen fertilizer and forget about the PK?
Uh, I would say yes, and then it depends.
Okay, of course.
And yeah, I look at it with home gardens. I see sort of a dichotomy.
Okay.
There's the the new subdivision. Somebody has bought a house and they're trying to establish a garden in what's been called builder's loam.
Yes.
The scraps left over from building the house and a
Lousy
bit of
soil.
subsoil. Yeah,
Yes.
yeah. Those ones, they're deficient in everything.
Right. Right.
Because if the developer put topsoil back on, they put about 2 inches, so it's black on top, but there's really not a good soil there.
Right.
Those ones, you will likely get a benefit from what we call a complete fertilizer.
Right.
Something that's a 12-12 or 15-15,
Right.
because a lot of those soils, and without a soil test, you won't know for sure. Some of them may have enough potash, but not enough phosphorus. Well, phosphorus is the one that's often limiting in a lot of those situations. The other side is somebody who's been gardening for 20 years and they've added compost and they've been putting mulch down, and they probably have far more phosphorus and potash in their soil than they will ever need.
Right. Yes.
And if they get if they're short on something, it will be nitrogen that we lose every year because of the winters we have.
Right. Yes.
So in that case, yeah, buying a 2100 or even a 4600.
Right.
And
to what extent so I mean, over the years, I've really tried to just use organic mulches to maintain the fertility of my soil. And I mean, I'd like to say it's always been successful, but then there's some years where things I got a number of beds where I'm noticing I'm cycling the cucumber. I got a row of beds that are 4 by 10, and every year I move the cucumbers over. Okay. and I've been
Okay.
growing in these beds. So when I first put these beds down, I used the existing soil and some horse manure, and that was 2014, I think.
Okay.
All those beds have gotten since then was mulch. No amendment whatsoever, just mulch. And the mulch is either leaves or hay or grass, some
Okay.
combination of those things. Maybe
Mm-hmm.
once in a while, I will mulch because I'm desperate. I'll mulch with wood chips or something like that. But I don't like to use wood chips, even though so many people are fans of them. I find the year after I use wood chips, and it's totally understandable, right? The year after it doesn't tend to work as well. And, I probably, if I'm going to use wood chips, I should be using some sort of high nitrogen fertilizer to follow up on it. But anyway, so yeah, I've noticed the cucumbers aren't like they were 8 feet high, they're 7 feet high, they're 6 feet high, 5 feet high. So I just bought 2 cubic yards of really well-aged manure a few weeks ago, and I've been adding some to all my
Mm-hmm.
beds.
Mm-hmm.
But yeah, I mean, to what extent do you think is it plausible? This is, I mean, natural systems, that's all they do, right? Stuff just falls
Yep.
to the ground
Yep.
and it breaks down.
Mm-hmm.
And so
Yeah, but in
there's
natural systems, we don't harvest anything.
we're not trying to grow giant pumpkins, and I mean,
Yeah,
exactly,
we're not taking stuff away.
right.
So nitrogen or natural systems, yeah, it cycles, and it
Flows,
doesn't go anywhere. We're
yes.
saying, okay, we want to have a productive garden. We want to take a big part of what we grow and use it in the
And the
kitchen.
most energy rich part.
Yes,
Like
yes,
somebody, we leave
yeah,
all the
yeah,
crap.
yeah, yeah, and we're not going and peeing and pooping back in the garden, so we
That's
break that cycle.
that's true too. After it comes, we're not. It's right. Yeah, that's what we should be doing.
Yeah.
Yes, exactly. That's a
There's been
really
some
good point.
interesting experiments with straw bale gardening where they actually use the straw as a growing medium, but by peeing on it regularly.
Yeah, yeah. There's a logic to that, right? That would probably work. So okay, that does make sense. Yeah, that does make sense.
Mhm.
Um,
But yeah, with your cucumbers, it quite likely is that they're short of nitrogen. Now, if you're adding grass clippings,
which
that's
is
high
what I
nitrogen.
do. And
That's high.
there's
That's high nitrogen. So
there's
you're
always results too. They're almost immediate. You'll have like kale is sort of in July. They're not super green, and you put like 2 inches of grass clippings down, and a couple weeks later, the plant's just like
oh yeah,
whoa, like it's
yep,
almost
yep,
it's very quick. A couple good rains, a couple weeks, and it's like you've
yep.
just given them a B12 shot. Um,
Well, you've essentially given them a shot of nitrogen fertilizer
yes,
because grass clippings there it's a lot of nitrogen relative to the amount of carbon.
yes.
It breaks down very quickly and it releases nitrogen into the soil.
Yeah,
So,
well, you can smell
it's
it. I mean,
yeah,
the layers. If you lift it up, there's all this white stuff, and it's
yeah,
just
yeah.
going crazy.
Hmm.
Um, yeah, that makes sense.
Yeah. So it's the case if you're and your limitation will be, well, where's the grass coming from?
Yes,
You're breaking the cycle somewhere.
well, that's the great thing.
I think.
So I got this big section of my lawn, which is my uh, septic field, right?
Okay.
Never needs fertilization ever.
So
Well,
you're
I am
recycling back through the septic tank out to the grass and then back to the garden.
I am pissing on the garden, just in a sort of roundabout way.
Yeah,
Exactly.
yeah,
That's exactly. I explained that to the kids once that we're eating our pee and poop.
yep.
Um, they thought that was gross, funny, and okay. Okay. Um, so we've touched on this a little bit, but it's worth asking because I know a lot of my viewers are into permaculture and that sort of thing. So we talk about how does nitrogen work in that? I mean, you look at a forest or you look at a field or a ditch, and no one's doing any work. There's nothing being added,
Hmm.
and they're getting, you know, every plant's getting what it needs, or at least it seems to be that way. So, do we have an idealized view of this? How do you explain the functioning of natural systems?
Natural systems. Yeah, Yes, my cynical side says, well, the plants that don't get everything they're needing just sort of fade away, and other plants outcompete them. That's
Yes.
uh, you know, if you look at a prairie system, often
Right.
that's the poster child for permaculture is a prairie culture. Well, a native prairie is a mix of deep-rooted grasses, some forbs, some sort of non-legume broadleaf plants, and a whole bunch of legumes.
Right.
There'll be clover plants, there'll be uh, sun hemp, there are a number of, it's not the usual ones we grow for hay, but there will be legumes in there
Right.
that are feeding that whole grass sward.
Oh,
And
like the Timothy and that sort of thing,
yeah,
or vetch
or
or
in
whatever.
that case it'll be the big blue stem, or
Yeah.
you know uh, whatever warm season grasses are there.
Yeah.
The other thing is those species of grass adapted to that prairie environment are very good at recycling back within the plant. So they'll grow in the spring, and then a lot of that'll move back down to the roots for the winter, and then that's there to they don't uh, sort of put out a lot of growth and then have it cut off and harvested and taken away.
Right.
So it's recycling. So that's the prairie system. There was some very interesting work done actually in the rainforest in BC, and you've got all these huge Sitka spruce and western red cedar, and how do they get so big? I forget the exact percentage, but it was more than half of the nitrogen in those trees came from salmon.
Oh, okay. I remember watching a Nature of Things
Yeah,
episode, and they were talking about the
the
bears
sam
leaving the salmon all
yeah
over the place.
the salmon are migrating up the streams. The bears are eating what they want, leaving the rest on the shore, and they're
Right.
rotting down and they're feeding the trees. And if you cut off the salmon, the trees would be nitrogen deficient.
And I imagine there's probably like a salmon belt. Like you've got your riparian, so you've got your
Yeah.
forest, you've got your riparian zone where there's things that grow near the river that don't grow anywhere else. And there's probably things that grow on behalf of these rotting salmon that just
Yep.
would not
Yep.
grow anywhere else.
hmm
That's it too. And also when you think about a forest, I guess you've got all these, like all the activities. If you go in the forest behind my house, and I mean the soil, the ecology here is like Newfoundland, where I am. Not Nova Scotia is weird. It's a very weird province. There's different ecologies in the
Yep.
province, right?
Yep.
So where I live, I call it the land of granite and spruce trees, sort of thing.
hmm
Um,
hmm
uh, so there's parts of the forest back here where it almost looks like someone planted it as a monoculture. This is just spruce trees. Or
Yep.
you'll be
Yep.
in an area where it's just pine trees, probably because the soil is extremely acidic in those
hmm
locations.
hmm
It's the only thing that can live there. And then you got these swamp areas where you got, your tamaracks, things like that can
hmm
handle all
hmm
that water. Um, but the soil there. If I brought some of that soil up and put it in a pot and tried to grow something in it, it would be. I've played around with it.
It would be pathetic.
It looks like beautiful soil. It's black and it's got
Oh
all
yeah.
this nice
Yeah. Yeah.
feel. And then you try to grow anything, and it's little tiny potatoes, and
Yeah. Yeah. Yeah.
just it's
Yeah.
amazing. Anything, the only thing that seems to grow in it are this handful of things, and we don't have this incredible variety here too.
hmm
There's
hmm
like 10 things in the woods, So when you see something that's different, it's on an edge, right? Where the
Yeah.
forest meets of kind of. We have fields here, but it's not grass, it's these bushes, this
Okay.
sort of, these weird kind of waist high bushes that rip your
hmm
clothes off and
Oh.
tear your pants up. you know or you might have that another edge where you're getting close to where the water is, on the edge of a
hmm
lake. You have a
hmm
completely different ecology there. So this narrow strip of, all of a sudden you start seeing choke cherries and things like this, right?
Right.
Which
Right.
they're not everywhere. They're in a certain spot. Or you have like
hmm
a
hmm
ridge where it's getting all day sun, and it's drier. So you have different things growing in those spots. But otherwise, it's all spruce trees and
Yes. Yep.
some
Yep.
birch
Where it's
trees and
something that's
some maple.
adapted to acidic soils and low fertility.
Yes, exactly.
Yeah, and if you add fertilizer, something else will come in that will outcompete them.
Yes. So it is something I was so enamored with the permaculture, the elegance and the beauty of the explanation for how natural
Hmm.
systems work. But it is a bit of an idealization when you compare to what are you growing in your garden? You're growing all these tropical foods that aren't even
Yep,
native to
yep.
here. And as you say, there's this huge energy extraction from the system, and you want this incredible productivity. We don't want the cucumber. If it was in nature, the cucumber would grow one little cucumber or two.
Yeah.
We want, I want one plant to give me 20 cucumbers about this big.
Hmm.
I want them to be perfect, right? Um, so I want a very different thing than the thing that just happens. And we sometimes
As I say, Mother Nature's always right, but she doesn't care about us.
no, and we'll see things that are growing. Like if you look at a chokecherry tree, for example, it is growing perfectly. It's productive. There's cherries everywhere, but it's growing in the one place for
Hmm.
kilometers that
Yep,
is ideal for that. That's why it's productive. You
yep.
couldn't just take some of the. You could take the seeds from that. You could take the berries from that chokecherry, just throw them all over the place. Um,
And yeah, you might get one other tree that grows that
yeah,
is
exactly.
productive. And
Yeah. Okay, so we've talked about why plants need nitrogen, how to make sure they have enough, but is there such a thing as too much? And how do you know that's happening, and what do you do about it?
yep, yep. And certainly, especially in a garden situation, it's easy to get too much in. That whole, if a little is good, more is better, can come back to bite us. Uh, First thing with too much in, you'll get a lot of green growth. Nitrogen drives vegetative growth, which is, if you want kale, hey, or you want lettuce, that's fine. That's wonderful. That's what you want. Um, there can be issues there if you've got too much nitrogen. You get high nitrates in your lettuce or in your kale,
Right.
which, if you're making a steady diet of it, is not good for your digestion. But more often, it's okay. I put more nitrogen down. I've got lovely big pepper plants. I've got lovely big tomato plants. I don't have any tomatoes.
Where's all my damn tomatoes? Exactly.
Yeah, yeah,
Right.
because everything's gone to leaves and nothing's gone to fruit.
Right.
You get that imbalance. So that's the first thing. You get too much vegetative growth. Go a little bit further, especially with the nitrogen fertilizers, but also with some of the manures. Uh, you'll get root burn. You'll get
Right.
actual harm to the roots because the concentration either of salts is too high, or of, if you have too much ammonium in the soil, uh, it will be released as ammonia.
Uh,
And, you know, too much ammonia around a root, it's like holding a lit match to a root, and
right.
you'll actually get them dying back. And of course, if you don't have the roots, you don't have top growth.
Yes.
Your plants do not do well.
I see.
Um, Another thing is, if we put too much nitrogen on, if plants don't use it, it will go off into the environment. So we'll lose it. We'll lose it through leaching. That's a huge issue in the potato belt, and uh, PEI in particular, where they're worried about nitrates in drinking water because of a history of high nitrogen on potatoes.
Right.
And what doesn't get used goes down into the water table.
Uh,
Yeah, or we have nitrous oxide losses to the air.
I've heard some people argue that if nitrogen's too high, that it somehow there's an argument that um, if the nitrogen's too high, it somehow invites increased pest damage.
Um,
Does that make any sense
there,
to you?
it does make sense. There may be some effect that you've got lots of lush, soft growth, if you like, which is going to be easier for a fungus to infect. I think a bigger impact is you've got lots of vegetative growth. You're holding humidity within that plant canopy, so you've got an environment where diseases can take hold.
Right.
Yes, so you will get more disease pressure if you've got excess vegetative growth.
Huh.
And especially if it's a situation where you're trying to maximize productivity from a small space, you get everything squashed together,
Yes.
and then you get all this lush growth, and there's no place for air to circulate around
Right.
that foliage. You're creating a condition where fungal diseases or bacterial diseases can take hold and do a lot of damage.
I see. All right. Um, and if you have too much nitrogen, what do you just, I guess you just have to wait, like wait for a good rain or what?
Yeah. That's one where if you see that situation, you're going, oh shoot, I did that wrong.
Right.
And that's really about all you can do. You can't, nothing you can add. If it's a small garden, you can, you know, water and try and wash it out, and that's what
I
they'll
guess you
do.
could
And
plant some heavy feeders, like plant corn, something that just, can't seem to get enough nitrogen, you
hmm
know.
hmm
Um, all right, Keith, this has been great. Good conversation on nitrogen. Always good to have you on the show. People, if you are looking for a great Christmas present to give yourself or someone you know who loves gardening, improving your soil is a fantastic thing to add to your gardening library. If I had to throw away everything and keep 5 books, that would be one of the books I kept for sure. Um, Keith, great having you on the podcast as always. Thank you so much.
You're quite welcome, and hope everybody learned a little bit.
Okay, everybody. Hope you enjoyed this video. If you did, please like, share, subscribe. Check out my Substack page, maritimegardening.substack. Check out the YouTube channel. And of course, avail yourself of the coupon code from Bessie Seeds. And until next time, get out there, get at it, have fun in your garden. Thanks for watching. Thanks a lot, Keith. Hey, if you want to help support everything I'm doing here, go to vessies.com to buy whatever you need for your garden this year. And use my coupon code GAVS23 to get free shipping as long as there's a pack of seeds in the order and there's no oversized items in the order. Check out the description box of this video for details. You can buy everything you need from Bessie's. They have seeds, fruit bushes and trees, soil amendments, pest solutions, tools, clothing, and lots of other stuff too. So yeah, if you want to help support everything I'm doing here and they sell something you need, buy it from them using my coupon code. And happy gardening.